Look at your hand right now. Whatever shade it is, that color didn't come from nowhere. It came from one of the longest and strangest makeovers in human history. Not random, not an accident. A slow-motion biological negotiation between your ancestors and a surprisingly rude star sitting 93 million miles away, with absolutely no regrets. Human skin color now spans an enormous range, from deep, dark tones near the equator to very pale tones in northern regions. It can feel like humanity has always looked this diverse. But the earliest populations of modern humans were likely dark-skinned. Modern humans evolved in Africa roughly 300,000 years ago under some of the strongest ultraviolet radiation on Earth. And every living human traces their ancestry back to those early African populations. So how did one species, with shared origins, develop such an enormous range of skin colors? The answer begins with something invisible. Ultraviolet radiation. UV light can damage DNA, cause mutations, and contribute to skin cancer. To defend against it, human skin produces a pigment called melanin. Melanin acts like a natural sunscreen. The more melanin your skin contains, the darker it appears, and the more UV radiation it can filter before that radiation reaches deeper tissue. Dark skin isn't just a look, it's a shield. Under the intense African sun, that shield was a powerful evolutionary advantage. Melanin helped protect the body from harmful UV exposure. It may also have helped protect folate, a form of vitamin B9 that is essential for healthy embryonic development. Folate is especially important during the earliest weeks of pregnancy, when the brain and spinal cord begin to form. Strong UV exposure can break down folate under certain conditions. So, darker, melanin-rich skin may have helped protect both the body and reproductive health. Two major biological pressures. One, powerful adaptation. Natural selection doesn't care about beauty. It doesn't care what looks good. It asks one question. Does this trait increase the chances of surviving and having offspring? In equatorial Africa, dark, melanin-rich skin was a powerful yes. But then humans began leaving Africa. Between roughly 70,000 and 100,000 years ago, groups of Homo sapiens slowly spread into the Middle East, Europe, Asia, and eventually the Americas. And as they moved farther north, something fundamental changed. The sun got weaker. Not the sun itself. The sun remained exactly as indifferent and nuclear as always. But at higher latitudes, sunlight hits Earth at a lower angle. It passes through more atmosphere. More UV radiation gets filtered out. Days become shorter. Winters become longer and darker. Suddenly, the same dark skin that was so useful near the equator created a different challenge. Because UV radiation isn't only dangerous. Your body also needs a small amount of UVB radiation to begin producing vitamin D. Your skin is basically a solar panel. When sunlight reaches it, a chemical reaction begins that helps your body produce vitamin D. And vitamin D is essential. It helps your body absorb calcium and phosphorus. Without enough of it, bones can become weak and soft. Children can develop rickets. Adults can develop serious bone problems. In a world with no supplements, no fortified food, and no modern medicine, severe vitamin D deficiency could affect health, growth, and reproductive success. Now imagine a dark-skinned population living in Northern Europe thousands of years ago. Their melanin filters UV beautifully, but sunlight is already weak. So less UVB reaches the skin, making vitamin D production more difficult. Over many generations, this created a new evolutionary pressure. Random mutations that reduced melanin began appearing. People with slightly lighter skin could potentially produce more vitamin D in low UV environments. That could improve health and reproductive success. So those genetic variants became more common. Generation after generation, slightly lighter, slightly lighter, slightly lighter. Not because anyone chose it, not because of beauty, not because one skin color was better than another, but because different environments created different biological challenges. The evolutionary algorithm had changed its inputs. But here's where the story becomes even stranger. For a long time, scientists assumed Europeans became lighter-skinned gradually as soon as they moved north. Ancient DNA revealed that the story was much more complicated. Early European hunter-gatherers remained relatively dark-skinned for tens of thousands of years. One famous example is Cheddar Man. He lived in Britain around 10,000 years ago. Genetic analysis suggested that he likely had dark to medium dark skin, dark curly hair, and light-colored eyes. That combination seems unusual today because we associate light eyes with pale skin. But that connection wasn't always common. Many of the genetic variants strongly associated with very light skin in modern Northwestern Europeans became widespread much more recently. So what accelerated the change? Farming. When humans shifted from hunting and gathering to agriculture, their diets changed dramatically. Hunter-gatherers often ate varied diets that could include fish, shellfish, organ meats, and other animal foods containing vitamin D. Many farming populations became increasingly dependent on cereals such as wheat and barley. For some populations, dietary vitamin D likely fell. That meant they became more dependent on the vitamin D their skin could produce. In northern regions with weak sunlight, lighter pigmentation may have become even more advantageous. And farming communities were larger and more connected. That allowed useful genetic variants to spread through growing populations more quickly. The combination of diet, population growth, migration, and natural selection may have accelerated the spread of lighter skin in parts of Europe. But skin color is not controlled by one gene. There is no single dark skin gene or light skin gene. Skin pigmentation is influenced by many genes working together, and different populations didn't necessarily use the same genes to evolve lighter skin. Europeans and East Asians both developed lighter skin on average than many equatorial populations. But many of the genetic changes involved were different. They reached similar outcomes through different genetic pathways. This is called convergent evolution. Different populations, environmental pressures, similar results. And there's one more detail that proves this story is more complicated than simply the farther north you go, the lighter the skin. Arctic populations, including Inuit communities, retained relatively darker skin despite living in regions with very little sunlight. One possible reason was diet. Traditional Arctic diets included fish and marine animals rich in vitamin D. That reduced the pressure to evolve extremely light skin. Other factors, such as ancestry, migration, local UV conditions, and sunlight reflected from snow, may also have played a role. So skin color wasn't shaped by latitude alone. It was shaped by sunlight, diet, ancestry, migration, and thousands of years of natural selection. Human skin color is not a set of fixed categories that existed from the beginning. It is a living record of how one species adapted to different parts of the same planet. Every skin tone carries the history of generations responding to their environment. And the color of your skin is not a story of separate origins. It is part of the story of one human family, changing, adapting, and spreading across the world. If your brain just did a little backflip, you're in the right place. Hit subscribe